2.2, we're going to continue our elemental review of the periodic table. We're going to do a real quick rundown of the periodic table and a little bit of periodic table math that has become a common staple last year and that you'll need to do almost every single day in here throughout the rest of the year, which any chemist should be able to do. So if we review here, we have symbols of elements. You guys know the symbols. We've had to do it a bunch of times. It's just common sense now. So elements are symboled by 1 or 2 letters. You know most of them, and they're all on the periodic table. Now, what will happen a lot of times is, you know, the atomic on the periodic table, the atomic number is the number on top, and that references the number of protons in the atom. So that references the number of protons. A lot of times, what you will see here is that you will see mass number and the atomic number may be given with the symbol. We haven't done that as much, but it may become more prevalent this year. So what you'll see is we have something like C, and we have 6 and 12. The number on the bottom is the atomic number. The number on top is the mass number. So hypothetically, you could see something like this. That's oxygen. Again, how many protons does it have? 8, because that's the atomic number on the bottom. And what's its mass number? 16. So remember, we use mass. In the lab, we use everything in grams per mole. Most typically, though, you will see everything referenced in AMU when we're talking very small atom-by-atom units. When we talk about atoms, remember, if you look at the atomic mass on the periodic table, it is not a whole number. Like oxygen is not 16. It's 15.99999. Carbon's 12.01. Right? Iron is 55.45. Why do we have an average, or why do we have a decimal as our number? Well, the reason is we have isotopes. And isotopes are atoms of the same element with different masses. So they have different numbers of neutrons. So for example, we just said carbon's average weight was 12.01. Well, why is that? That's because there are 4 different isotopes of carbon. Carbon 11, carbon 12, carbon 13, and carbon 14. And as you can see by the table, the only thing that differs is the number of neutrons. You can also see here on the bottom a little note, 99% of carbon that exists is carbon 12. So carbon 12 is the dominant isotope. With some other elements, it is not nearly as dominant as 99%. Sometimes it's split 50-50. Sometimes it's 30-30-30-10 if there's 4 of them. So that is why we have average atomic mass. And we can figure out the atomic and molecular mass of compounds with great accuracy using a mass spectrometer, which is a device which kind of helps figure out the weight of compounds. And we don't have to get into exactly how it works. As I was just talking about, the average mass of a compound is isotopes. Why is it average mass? We have to calculate it. So you might get a problem, and we will go over this in class, is you will get a problem of figure out the average mass of the compound. And remember, it'll say it's 75% of it weighs 12, 20% of it weighs 13, and let's see, 5% of it weighs 14. What is the average mass of that compound? And you are going to have to formulate something called a weighted average. So remember last year when you did this, you really would take 75 times 12, get a number, 20 times 13, get a number, 5 times 14, get a number, and then you would divide that all by 100, since you had 100%. Or if you wanted to do it likewise and not divide by 100, instead of taking these as percents, you could convert them into decimals and go 0.75 times 12 plus 0.20 times 13 plus 0.05 times 14. Add that all up, and those two numbers would be the same, and you'd have the same answer for your average atomic mass. So we've talked about average atomic mass. We've talked about atomic numbers. Let's go through real quickly on the periodic table. We know the periodic table is systematic. That is common. All right, that is common knowledge. The elements are arranged in a particular pattern because they have distinct characteristics. They're not just arranged randomly. Remember, they're arranged in order by the atomic number. There are two ways that you can go on the periodic table: horizontally, which are called periods, and vertically, which are called groups. Groups sometimes are also called families. Groups have very distinguishing characteristics. For example, we know that the alkali metals, group 1, react very vigorously in water. That is a characteristic of that group. We know that group 18 or 8A, depending how you want to reference it, the noble gases are inert. They don't like to react very much. Those are common characteristics. When we go side to side or horizontally as a period, remember that elements that border one another have some distinguishing characteristics. Bromine and krypton may have a few characteristics in common. However, if I was to compare bromine with potassium, since they are so far away, they have virtually nothing in common. So kind of something to keep in mind. Periodicity is what we call this when we range all the elements on the periodic table and we find common links together. So you can see here 3, 11, 19, all three of those that are in green have something in common. They're all soft reactive metals, and when they are placed in the periodic table, they are put in the alkali metals. Groups that you know or should know, just to review, you know that the first group is the alkali metals. You know the second group is the alkaline earth metals. Do not worry about 6A. 7A is the halogens. That's the second to last group on the periodic table. And the last group is the noble gases. We're going to talk about metalloids and the transition metals as well. These 5 groups are known by their names. We talk about nonmetals. Remember, nonmetals is anything essentially to the right of the steps. Metals is everything to the left of the steps. Now, when we talk about metalloids, last year we kind of just classified it as everything under the steps. There's a lot more broader definition, much more specific definition for those. It's the elements that border the steps, with the exception of aluminum, plutonium, or not plutonium, PO, and that's slipping my mind. It's polonium, excuse me. PO is polonium, and then AT, astatine. So those 3 elements are not metalloids. So there are really only 6 metalloids. So kind of keep those in mind, elements that border the steps except those 3. So if you are to the right of the steps, you are a nonmetal. Left of the steps, metals. And the ones that border the steps, with a few exceptions, are the metalloids. And that is going to conclude our little tour through the periodic table. Where we will start going for the remainder of Chapter 2 is naming compounds. So we will practice a little bit with math tomorrow, and then we will move on.